Dear students of class 10, today we will discuss a creative question from exercise 4, that is exponential and logarithm. At first, look at a creative question. Here is the stem. Here, in first information, there's a is equal 4 to the power 2p plus 1. Small a is equal x to the power p divided by x to the power q. B is equal x to the power q divided by x to the power r, and C is equal x to the power r divided by x to the power p. Here the three questions are: A, if A is equal this 128, then we have to find the value of P. In B, we have to prove this and this is equal 1, and in C, we have to show this is equal 0. So there are three types of formulas we can use here. Okay, when we go to the solution of A, here a is equal 128, and in stem we have a is equal 4 to the power 2p plus 1. In power there is a p, and we have to find the value of p. How can we do that? Suppose given that a is equal 4 to the power 2p plus 1, and according to the question a is equal 128. Here according to the question a is equal 128. So instead of a, we can write down 4 to the power 2p plus 1 is equal 128. We all know if the bases are equal, then we can write the powers as equal. Since we have to find the value of p, which is in power, so we must equate the base. How can we do that? Here the base is 4, and 128, it cannot be written as the base of 4, but it can be written as the base of 2. That is, 128 can be written as 2 to the power 7. So we can do this simple thing. We can make this 4 as the base of 2. 4 is equal 2 square. So instead of 4, we write 2 square. In the fourth line, this 2 is a power, and 2p plus 1 is also a power. So here power and power is multiplied when there is only one base. Here is only one base. This one is power and this one is power. So we can multiply these two powers. If we multiply 2 with 2p plus 1, we get 4p plus 2. And then the equation becomes in this way. Here base is 2, another in here base is also 2. So there is another rules. To find the value of exponent or power, we must equal the base. Here we equal the base, and then if the bases are equal, then we can write the powers as equal. So here we can write this power and this power as equal. Hence, by simple calculation, we can get 4p is equal 5 by exchanging 2 into that side. It is plus, then it will become minus, and 7 minus 2 will be 5. So p will be 5 by 4, and that is our answer. So in question A, we find these two basics. First, to find the value of exponent or power, we must equal the base. This is 1, and the next one is, if the bases are equal, then we can write the powers as equal. We get another basic. Power and power is multiplied when there is only one base. So in solving A, we get these three basics. Okay, fine. Now we will solve question number B. Look at the question. We have to prove this is equal 1. So in B, at first we write down the left hand side, that is this is our left hand side. At first, in second line, we put the value of a, b and c. What is that? In STEM, we are given a is equal this, b is equal this and c is equal this. So we put a this, b this and c this, and the other things are unchanged, that is in power 1 by pq, here 1 by qr and here 1 by rp. Okay, in third line we write x to the power p divided by x to the power q as x to the power p minus q. Why is that? Here is a simple basic, and the basic is, if there are more than one base similar and they have multiplication sign, then we have to write only one base and the power will be added. So there are two bases, but here is the division sign. First we read, if there is a multiplication sign, so there is another rules. If there is a division sign, then the powers will be deducted. So we do the simple basic x base, and this power will be deducted, p minus q, and this power will be unchanged. We do the similar thing here, x to the power q divided by x to the power r. There are two base similar x and there is a division sign, so we can write one base x and the powers will be deducted, q minus r. Similarly, we do the same thing here. X base are same and there is a division sign, so we write one base x and the powers r minus p. Again, in previous question A, in number A, we see that the powers will be multiplied if there is only one base. So p minus q and 1 by pq will be multiplied. It will become p minus q divided by pq. The similar thing we do here. These two powers multiplied, it becomes q minus r divided by qr, and similarly these two powers, if we multiply, then it will become r minus p divided by rp. Here, look, again the basic has come, x, these three base are equal and that is x, and there is multiplication sign. So if we look at this basic, if there are more than one base similar and they have multiplication sign, then we have to write only one base and the powers will be added. So these three base with multiplication sign between them, we write one base and the powers will be added. This power and this power will be added. So when these powers we will do the adding, then the LCM will be PQR and the rest of calculation will be in this way. We can cancel this PR by minus RP, minus QR plus QR, so this will also be cancelled, and plus PQ minus PQ. So in numerator we will get 0 and denominator PQR. 0 is divided by any number always become 0, so we get x to the power 0 and hence it will be 1. This is another important basic, and that is, if the power is 0 of any base, the value of it will always be 0. Hence from here we write 1, and then what we had to prove we already proved. So number B is done. Now we see the question number C. Here we have to show that this is equal 0. This is the math of logarithm, so we will do it now. At first we write down the left hand side. The left hand side is this: p plus q into log a plus q plus r into log b plus r plus p into log c. In second line we write log a to the power p plus q, but here there was p plus q log a. Why is that? there is another basic. Look at the basic. Anything that appear before log can be written as its power. So here p plus q appear before log, so we can write p plus q as power. We write it log a to the power p plus q. The same thing we do in the next two portion. Log b whole to the power q plus r and log c whole to the power r plus p. Now we replace a, b and c by their values which is given in the stem. A is equal this, b is equal this and c is equal this. So I think in third line we don't have any problem. Again in the fourth line, log x to the power p minus q. Why is that? That is the simple basic we did earlier. If the bases if there are more than one base similar and they have not multiplication sign, here there is a division sign, then the powers will be deducted. We do the same thing. X, the base are same and there is a division sign, so x to the power p minus q, and this p plus q. Same thing we done the next two portions, that is log x to the power q minus r, and this power is same, and here x to the power r minus p, and this power is same. Again the basic we learned earlier, this power and this power will be multiplied. Why? Because there is only one base, so p minus q and p plus q will be p square minus q square. These two if we multiply, then it will become q square minus r square, and these two powers if we multiply, then it will become r square minus p square. Now this line has been done. Okay, in the next line, here is another basic. Look very carefully. Log this plus log this plus log this. Suppose this is m, this is n, and this is r, or like that. So we have an important formula, and that formula is log m plus log m plus log p will be log m into n into p. So these three log will become only one log, and the numbers m, n and p will be multiplied. We apply the same rules here. What is that? Log m plus log n plus log p will be log m into n into p. So log, there is the same base x, x and x, and they have multiplication sign, so we can write only one base and the powers will be plus, and this plus this and this. If we cancel all the things, then we will get 0, and we know the basic again. If the power of 0 is the power, if the power is 0 of any base, the value of it will be 1, so x to the power 0 will be 1, and hence log 1 is equal 0. This is another formula, you have to keep it in mind. Log 1 is equal 0, and hence we find 0, and that is our right hand side. So left hand side is equal right hand side, proved. Inshallah, I think and I hope you will understand. Just look it carefully and think all the formulas and basics. Inshallah you will get it. Assalamu alaikum.